We are actually going to find the derivative here using logarithmic differentiation, and we can express this radical as a 1/2. Now what we want to do is we want to take the log of both sides. And the reason that we would take the log of both sides is because then we could apply log properties to this right-hand side. So the third property of log says that I can multiply this exponent out in front as a factor. And so I would have the natural log of y equals 1/2 natural log of, now I have a quotient, so I can take the log to each piece if I subtract between them, and I either need the 1/2 out in front of the whole thing or I've got to put it on each piece because it was on both of these, x to the 4th minus 1. So now that I have this expanded using log properties, I'm going to use implicit differentiation. So the derivative of the natural log of y is 1 over y times y prime. Remember, we've got the chain rule going on. Then we have constant 1/2 times the natural log of x minus 1. Well, that's 1 over x minus 1, and then the chain rule times the derivative of this, but that's a 1, so we've got that. And then minus 1/2, we've got the natural log of some stuff, so times 1 over the stuff times the derivative of the stuff, and the derivative of this is going to be 4x to the 3rd and minus 0. So we now have done the implicit differentiation, and we want to know what the derivative is, so we need to multiply both sides by y. Now I know what y is because it was given to me in this original problem, and so we'll want to replace the y with that as we finally write an expression for the derivative. And so that expression for the derivative looks like it's going to be 1 over 2 times x minus 1 minus, and we can reduce here by 2, so this is going to be 2x cubed over x to the 4th minus 1, and then multiplied by the square root of x minus 1 over x to the 4th plus 1.